Hi guys, welcome back to my channel. Let's become a bite better. Before we move on to the solution, I strongly recommend to pause the video here and give a try to the question by yourself. I hope that you have given a try to this question by yourself. Now let us solve this problem step by step together. Today we are solving a classic LeetCode medium problem that blends graph traversal with optimization. Find the closest node to two given nodes. This problem is full of small traps you don't want to fall into. Imagine you have a directed graph with n nodes, but here's a twist. Each node has at most one outgoing edge. This means every node either points to another node or it's a dead end. You are given an array edges where edges I is equal to j means that there is a directed edge from node I to node j. If edges I equal to minus 1, it means node I has no outgoing edge. For example, here node 3 is minus 1, which represents that node 3 has no outgoing edge. Now, given two nodes, node 1 and node 2, your task is to find a node that is reachable from both, such that maximum of the distances from node 1 and node 2 to that node is minimized. From node 0 to 2 is distance 1 and from node 1 to 2 is distance 1. The max of those two is 1 and you can't do better than that. So the answer is 2. Simple enough, right? But here's where it gets tricky. The graph may contain cycles. You have to track how far each node is from node 1 and node 2. And remember, multiple nodes may tie on distance. Pick the one with the smallest index. Let's solve it step by step. We will use a helper function to simulate a transversal, not BFS or DFS exactly, just following the path from a node since each node only has one neighbor. This gives us a distance from start node to every node it can reach. We do this for both nodes. Now loop through all nodes and find the one reachable from both, where the maximum distance is the smallest possible. And finally return the answer. This problem is a great reminder that you don't always need BFS or DFS when the graph is linear or sparse. Understanding the structure helps you simplify. Now let's just code it up fast. Let me just do the initializations. Now calculate distance from the start node to every node it can reach. Do this for the second one also. Now loop through all the nodes and find the Now loop through all the nodes and find the one reachable from both, where the maximum distance is the smallest possible. And finally, return the result. Here distance of current equals to -1 ensures that each node is visited only once. And finally return the result. We can clearly see that we are using the for loop and the while loop independently, so the time complexity will be order of n and space complexity will also be order of n, which is used for storing the distances. If this breakdown helped you, hit a like button and subscribe for more algorithm deep dives. Got a question or a different approach? Drop it in the comments. Until next time, keep thinking like a problem solver. See you in the next one.